Alright, this video is going to be entitled Cartesian Line Distances Part 1. Okay. And here's what we're going to do. Alright, we now know the Cartesian coordinate system because I covered that in a previous video, but for a brief overview, okay, we have a horizontal axis here, we have a vertical axis up here. Okay. Now, if you go in the right direction, that way, okay, you have positive 1, 2, 3, 4, and so on and so forth. All these numbers here will be positive. If you go in the left direction, you're going to have negative numbers. Negative 1, 2, 3, 4, and so on and so forth. Now, what about the vertical axis? If you go up, well, you know what? When the sun rises, it's pretty cheery and sunny, at least for most people. So now you got positive 1, 2, 3, 4, and 5. Now what if you start going down? Well, that's going to be negative 1, negative 2, negative 3, negative 4, negative 5. Let me tell you something. If you're skydiving, okay, and your parachute and your backup parachute fail to work, you're not going to be too happy when you start going down. Okay, it's going to be a pretty miserable experience all the way until you hit the ground, and it's going to be a really bad experience. So, if you want to remember, going down is a really bad experience, well, there you go. Anyway, we have 2 points on this line. See this line right here? Now this line should have passed through the center here. And I'm sorry it didn't. But anyway, it should have. Okay? Anyway, we have 2 sets of coordinates. Negative 3 and 2, 3 and negative 3. Now, whenever you write down coordinates, what you do is you give the horizontal coordinate first, then the vertical. This is the horizontal, this is the vertical. This is the horizontal, this is the vertical. Alright, now let's go down here. When a variable has a number underneath it, that's called a subscript. If a variable has a number above it, that's called a superscript. Now, I covered that in a previous video, but I just thought I'd cover it again. So now we have 2 subscripted variables here. These are subscripted variables. We have 2 of them. We have another 2 over here. Well, here's the 3 and negative 3 from here. Here's the negative 3 and 2 from here. Now, what's our objective? We need to find the coordinates of the point which is exactly equidistant from here to here. Okay, so the same distance from here to here will be the same distance from here to here. How do we find those coordinates? Okay, well, we take the first set of coordinates from each one of these. Okay, we take the 3 here, we take the negative 3 here, we put them right here. And if we add them together, that produces a 0. Okay? Now, even if you divide that by 2, it's still going to produce a 0. So the coordinate, the x-coordinate of the point that is equidistant from here to here and equidistant from here to here is 0. Okay, so now we found the x-coordinate. How are we going to find the y-coordinate? How far up on this line is this point? Okay, now we have y1, which is negative 3, y2, which is 2. We add them together and we have negative 1. Negative 1 divided by 2 would be a negative 0.5. Okay, so your coordinates are going to be 0 and negative 1/2. So this line will pass through the horizontal axis at 0, but the vertical axis it'll pass through at negative 0.5, which isn't too far off from 0. Now you say, well, why do we need to know all this? Because I'm going to show you a mathematical formula that's going to be even weirder than what you just saw, and you need to know this in order to understand that. I will tell you more in a future video, so stay tuned.